All right, let's take a look at the sine curve. Now, we're going to have a look and see how we calculate the amplitudes at various parts through the cycle. So along this axis here, the x-axis, we've got the cycle in degrees. Along the y-axis, we've got the amplitude. Now, depending upon what this was, I mean, for example, my background would be in things like acoustical and electrical engineering, and so the amplitude here might be in volts, for example. So if this was, say, mapping the wave of a loudspeaker, this might be the number of volts as it passes through its cycle. So if we were to have a look at the values here, in this case, we're going to find what would be how far through the cycle would this have passed to have a value, an amplitude value of 0.4. And that's really what it's asking. So I'm going to make a note of that now. So the question really is, how far through its cycle would the wave have passed I'll put from the nearest no motion position, or if you like, zero position, I'll say no motion position, for a very good reason, because I would be dealing, for example, with loudspeakers, and this would be representing the loudspeaker, I suppose the frame of the loudspeaker, the diaphragm of the loudspeaker moving in and out. So how far through its cycle would the wave have passed from its no motion, or from its zero position, to reach the given amplitude? Okay. Now, what does that mean? All right, let's have a look. So here we go. We've got sine x is 0.4. So to find that, of course, we could just go sine x is equal to 0.4. So x must be the arcsine of 0.4. And let's go ahead and do that. So the arcsine of 0.4, here it is. So arcsine 0.4, bang. 23 point, I'm going to call that 23.6 equals 23.6 degrees. So, and there's my answer. So if I was to look at here, yes, we've got 23.6, nearest no motion position, that's our starting point here, 23.6, and we're going to get, a 0.4, there it is. So there's our 0.4, 0.4, and this is going to be about 23.6 degrees. But that's just one position. So that's 0 degrees. Let's have a look here. Oh, the answer, though, it says, look at the answer. It says the answer is not just 23.6, it's 156.4. Well, why is that? Because if we take this no motion position here and we go 23 degrees in this direction, we get 0.4. Or if we go 0.4, we move along, we end up with 23. But if we keep going along this path here, this 0.4, we come across another value here. And what is that value there? Well, that value, just as this is 23 plus 0, this is the next no motion position, the next zero position, it's 23.6 minus this position. So if we took 180, there was 180, 180, and we took off that 23.6, we'd end up with 156.4, which is where that value there comes from. So each time it's going to be from the no motion position, the zero position, where is the nearest value if we go for 4.4, yeah? So in this case, it's 23 degrees for this way, 23 degrees this way. And that's what we're calculating. So let's have a look at another one. Here we go. So let's have a look at sine x is negative 0.83. Now this is a bit of a trickier one. So let's have a look first of all what that would be. So I'm going to go sine x is equal to negative 0.83. So x must be equal to the arcsine of negative 0.83. And that is equal to, let's have a look. So the arcsine, and this is where things get a little interesting, an arcsine of negative 0.83. We end up with negative 56.1, I'm going to call that. Negative 56.1 degrees. Well, what on earth does that mean even? Negative 56.1 degrees. Well, let's have a look. Well, remember, this is finding how far this wave here has passed through its cycle to get to negative 8.83 on the amplitude scale. And it's going to be the nearest no motion position. So let's have a look. So if we were to go, for example, have a look at 0.83, negative 0.83, well, here is negative 5. Negative 8 is about there. So it's going to be somewhere around sort of here-ish, yeah? And it's going to be here and, say, here-ish, around there somewhere, yeah? And in actual fact, if we have a look at this, we're going to find it's going to be 236 and 303. So it's going to be a little bit on this side here. It's going to be around there, and it's going to be 303. It's going to be about there. That's what it's saying it's going to be. So that's going to be 236 degrees there. And this is one here is going to be 303 degrees there. But there's a reason why it's negative 56.1. Because the nearest position when the amplitude is negative 0.83 is actually back here. Because this keeps on going, yeah? Because that wave keeps on going. So where's the nearest position? There it is there. It's going to be that same thing there, but carrying along over here. There it is. That's our nearest negative. And how far back is this? That is negative 56 degrees. So this here would be 56 degrees. And it's negative because it's back beyond the 0 point. So that's going to be negative 56 degrees. But it's just 56 degrees from the nearest no motion or 0 position. So we can just go to any zero or no motion position and ask where is the nearest point that is a negative 0.83. Well, here's another one. Here's that. So if we were to travel in 56 degrees in this direction here, we're going to end up here. In other words, if I took 180 and I added on that 56, what am I going to get? Well, there it is there. I get 236. Or if I was at 360 and I took the next nearest, well, where's the next one? Oh, it's 56 degrees back that way. So in other words, if I took 360 and I took off that 56, I'd end up at about 303. That's all this is saying, yeah? By the way, it's 303 because this is not as 56.1, so you have to take off the 56.1. So that is all that is saying. Hope that makes sense, folks.